Hello students. So in this video we are going to discuss the question and answer of this chapter, work and energy. So I hope you have understood the chapter, and side by side you will be preparing notes also from this chapter by yourself, okay, as well as exercise questions. So exercise questions I will be helping you today, and from inside the book you have to make few questions. During the test or exam I place few questions from inside the book, so you have to prepare inside the book as well as the exercise questions. So let's start our video today. So exercise, first we have name the following. You see, the force applied on an object causes it to move in a direction of. So first question we have here. So what is called this when force applied on an object causes it to move in the direction of force? That is work. Okay, WORK, work. So number one answer is work. Next we have SI unit of work. What is the SI unit of work? That is joule. Okay, so in the bracket you will be writing capital J. Next we have ability of a body to do work is energy. Okay, so next answer is energy. Number 5, the energy that an object has due to its state of motion, that is kinetic energy. Okay, kinetic energy, so you will be writing in full wordings like kinetic in full spelling. Okay, next the energy that an object has due to its position, shape or state, that is potential energy. Okay, next number 7 we have the energy stored in an object as a result of its vertical position or height, that means gravitational potential energy. So number 7 is gravitational potential energy. Number 8 we have work done per unit time, that is power. We know power equals to work done per unit time. Okay, that is joule per second. So this is the unit of power, or we can say watt. Okay, so these are the units of power. So next we have choose the correct option. In the choose the correct option, first question we have which of the following is an example of work not being done. That means out of this four option, when we consider that work is not being done: climbing stairs, walking, thinking a lot, squeezing a balloon. That means thinking a lot. Okay, so whenever we apply force and if there is no displacement, we say there is no work done. And thinking a lot, that is a mental, we mentally we do work, but as there is no movement, we say thinking a lot has no work done. So answer of B is option number C, thinking a lot. Next we have the formula of kinetic energy is half mv square. Okay, so this is the correct answer. So number 1 we have done. Number 1 option is C. Okay, C. And number 2 answer we have half mv square. Okay, so this is the answer. So I have highlighted the answer here. Next number 3, when the height of at which an object is placed is more, the potential dash. So question is saying that when the height at which object is placed is more, the potential energy will will be more, because potential energy is depends upon height. So more the potential energy, more the height, and conversely is also true. If height is more, so potential energy will also be more. Next question number 4, an object can have elastic potential energy when it is stretched, bent, compressed, all of this. So it is all of this. Okay, so if we stretch also, if we bend also, if it is compressed also, then also it is potential energy. Next we have Question number 5. For a simple pendulum bob, the point at which kinetic energy becomes maximum is. So I need to show the diagram of this. This, right? So at this position, at A and at B, it is at extreme position. So it is having a maximum displacement from the mean position. So this displacement is maximum. So we say if when there is maximum displacement means maximum position from the zero position, we say that potential energy is maximum. Here potential energy is maximum, right? But here at this point O position, kinetic energy is maximum. Okay, so in this position we say that kinetic energy is maximum, right? So at which position potential energy is maximum? Potential energy is maximum at extreme and kinetic energy is maximum at its mean. So O position, 0 position, this is called mean position, and this is called A and B, this is called extreme position, right? So what was our question? For a simple pendulum bob, the point at which kinetic energy maximum is at its mean position. Okay, so this will be the answer. Number C. Solar panel converts electrical energy to light energy, heat energy to light energy, light to electrical energy to sunlight energy. So answer is option number C. Okay, light to electrical energy. Next, write true for T for true and F for false. That means true and false. Here you need to uh, tell these statements whether it is true or false, and you have to correct those statement also. Like question number 1, the more is the speed, the more is the kinetic energy of the object in motion. That is true. The first answer is true. Kinetic energy is also called stored energy. That is false. Okay, so number 2 is false. Okay, and the reason you will be writing, potential energy is also called stored energy. Okay, first you write this one, kinetic energy is also called stored energy, then you will write false, and in the next line you will write the correct sentence. You will write potential energy, so in place of kinetic energy you will write potential energy is also called stored energy, right? So next we have elastic potential energy is due to stretching or bending. Number 3, that is true. Okay, so number 3 is also true. Number 4 we have, when the speed is doubled, kinetic energy also gets doubled. So when speed is doubled, kinetic energy is also doubled. That means we know kinetic energy, here we can mark like kinetic energy, we can say half mv square. Okay, half mv square. Now when this velocity becomes double, so we can say half m into 2v square. Okay, so this was kinetic energy 1, this is kinetic energy 2. Okay, so kinetic energy 1, this is the original kinetic energy. Now when this velocity becomes double, that means 2 2 ja 4, so 2v whole square means 2 2 ja 4, 4v square. So kinetic energy becomes 4 times. Okay, not double. So this statement is wrong. So when kinetic energy, when velocity becomes double, kinetic energy becomes 4 times. So number 4 answer, that will be false. Okay, so reason you will write, when speed is double, kinetic energy also gets 4 times or quadruple. QUAD, quadruple or You can say 4 times. Okay, next, number 5. In an oscillating simple pendulum, at any point the sum of kinetic energy and potential energy is a constant. That is true. Okay, next, number 6. A 25 watt bulbs convert 25 joule of energy in 1 hour. So number 6 is false. Okay, the correct statement is a 25 watt bulb converts 25 joule of energy in 1 second. Okay, so in place of 1 hour, so you will be writing 1 second. Okay, so next we have choose the correct option to fill in the blank. Dash is done while standing at a place and holding a heavy load. That means no work is being done. Whenever work is done, there is always a transfer of energy. So next option is transfer of energy. Question number 3. Water stored at a height has gravitational potential energy. Number 4. At the extreme position of a simple pendulum, it has only potential energy at extreme position. Just now I have shown you. Number 5. When the water falls from a height, dash potential energy of water gets converted into kinetic energy, or kinetic energy of water gets converted. So potential energy of water gets converted to kinetic energy. Okay, so these are the answers. Next we have give reason for the following. In physics, work is not done when you push a wall. Now, what is the reason behind this? So you will write, in physics, work is not done when we push a wall because there is no displacement of the wall. Okay, so because there is no displacement of the wall, and we know work is done when a force is applied and an object moves to a certain distance. Okay, I repeat the answer. In physics, work is not done when we push a wall because there is no displacement of a wall. And in physics, work is done only when force is applied on an object and an object moves to a certain distance. Next question. If a truck and a car are moving with a similar speed, truck will have more energy. So answer you will write, a truck will have more energy because the mass of truck is more than that of car, and so kinetic energy of truck will be more than that of car. I repeat this answer. Question was, if a truck and a car are moving with similar speed, truck will have more energy. So you will say truck will have more energy because mass of truck is more than that of car. Full stop. Then we will say kinetic energy of truck is more than car. Okay, is more than car. Okay, so this one you will write, because kinetic energy equals to half mv square. So it depends upon mass and it depends upon velocity. Okay, so you will be writing like this. So you can include at the last portion also, because kinetic energy depends upon mass and velocity. Okay, this last line you will write in this question. Number 3, when speed is doubled, kinetic energy becomes 4 times. Just now I shown you that kinetic energy, first you will write kinetic energy equals to half mv square. Okay, so this is kinetic energy 1. Next, kinetic energy 2, you will write half m 2v square. Okay, 2v square. Now this one, number second equation, you can write 4 into half mv square. Okay, why 4? Because here 2 2 ja 4, 4v square, that means 4 can be written front. That means 4 into kinetic energy 1. So at last this equation can be written as, you see, kinetic energy 1 equals to 4, or kinetic energy 2 equals to 4 kinetic energy 1. Okay, so this one you will copy. So first you will write kinetic energy 1 equals to half mv square. Second you will be writing here kinetic energy 2 equals to half m 2v square. Then in the next line you will write 4 into half m v square. Then you will write kinetic energy 2 equals to 4 times of kinetic energy 1. So kinetic energy 1 means initial kinetic energy, and kinetic energy 2 means final kinetic energy. So this is the proof of this question. Okay, question number 3. This question number 3 answer is this one. Okay, so you will copy this one in your, you will just pause your video and you will just copy. Right, next question we have here. A rock on a cliff has more energy than a rock resting on the ground. So you will say the potential energy of a rock on a cliff is more than the rock resting on the ground. Okay, so potential energy of a rock on a cliff has more energy than the rock resting on the ground. Next question we have number 5. A rock of higher mass resting on a cliff has more energy than one which has less mass at the same height. Okay, so you will say potential energy depends upon mass. Potential energy depends upon mass, height, height, and acceleration due to gravity. Okay, acceleration, acceleration due to gravity. Okay, that is potential energy equals to mgh. So first you will write this one, potential energy depends upon mass, height and acceleration, therefore I dot e, that therefore potential energy equals to mgh. Then you will say the rock on the cliff having more mass has more potential energy. Okay, so a rock on a cliff has more energy than a resting on the ground. The question was this. So you will write potential energy of a heavy mass. Okay, so question number 5 we are doing actually. A rock at a higher mass resting on a cliff has more energy for, and then one which has less mass at the same height. So number 5 answer will be potential energy of heavy mass is more than that of body on the same height having less mass. Okay, so potential energy of heavier mass is more than the body placed at the same height of less mass. Number 6, a 60-watt bulb glows better than a 25-watt bulb. So 65-watt bulb glows better than 25-watt bulb. So reason behind this one, a 60-watt bulb converts more amount of energy in 1 second than a 25-watt bulb and gains out more light. So this is our answer. Okay, so this one you need to write. So distinguish between following: force and work, kinetic energy, potential energy, elastic potential energy, gravitational potential energy, mechanical energy, and kinetic. So these questions you will be doing by yourself. Okay, so force and work, first you will write the definition, you can write its formula and you can give one example. Similarly, kinetic energy, you can mention the definition, you can mention the formula, and you can give one example. So 3 differences you need to write. Elastic potential energy and gravitational potential energy also same definition, expression, and you can give the example. So likewise, distinguish by yourself, will be doing by yourself. How do you measure work done? So answer is here, work done, the amount of work done, the following factors can be considered. So how will you make this statement? So what was the question here? Question was, how do you measure work done? So work done can be measured by two factors. You will write work done can be measured by two factors. They are, number one, force applied, number two, the distance through which the object moves in the direction of force. Okay, so next question, define 1 joule of work. So 1 joule of work, from here to here you will be writing 1 joule of work is said to be done when a force of 1 Newton acting on an object moves it by 1 meter in the direction of the force. Right. Next question, define mechanical energy. Can a body have energy even it is not is in motion? So mechanical energy, you see here, kinetic energy and potential energy are together called mechanical energy. Okay, or you can say the sum of kinetic energy and potential energy are called mechanical energies. So you can apply here the sum, SUM, the sum of kinetic energy and potential energy together is called mechanical energy, right? Next question we have here, on what factors does gravitational potential energy depend? So gravitational potential energy depends upon, just now I told, it depends upon mass, it depends upon height and acceleration due to gravity. So number 5, name any two example for conversion of energies between kinetic energy and potential energy. So you can give these examples. Energy conversion in simple pendulum, this is one example, and one example you can give, energy conversion in roller coaster. Okay, so next question we have, define the law of conservation of energy. So law of conservation of energy states that energy cannot be created nor be destroyed, it gets transferred from one form to another. Okay, next, write the energy conversion in steam engine and wind turbine. So what is the energy conversion here? So you see one table we have in our book, this one, from here steam engine and wind one you need to write here. So in steam engine, heat energy gets converted to mechanical energy. In wind turbine, mechanical energy converts to electrical energy. So likewise, we'll solve for the questions. Next question we have, define power. What is this SI unit? Okay, so power questions. So this also we have a direct note in our book. You see. So in the power question, power, or directly you can see it is there in your book, power equals to amount of work done per unit time. That means work done per unit time can be defined as power here. So this was a gravitational potential energy note. Name the following answer. So you just check in your book. Okay, so I have not seen in the notes here. In my note it is not there, but power you can write here. What is power? Power is defined as work done per unit time, and the SI unit of power is watt, WATT. Okay, so what do you mean by kinetic energy? On what factor it depends? So this one, you know, kinetic energy depends, is defined as the energy possessed by a body by virtue of its motion. It depends upon mass and velocity. So likewise you will search your answer, okay, from your book. Explain gravitational potential energy, derive its formula. Okay, so derivation not required here, just you will explain the potential energy and you write its expression. explain the conversion of energy in oscillation of a simple pendulum and using a diagram. So simple pendulum diagram, you need to draw this one, right? And you need to explain this point, at what point potential energy is maximum and at what point kinetic energy is maximum, and at last you will say total energy at every point it is conserved. Okay, so this one you will say. Next, explain energy conversion in roller coaster ride. So in the roller coaster ride also you will see, so you need to explain at what position potential energy is maximum, at what point kinetic energy is maximum. Okay, so explain energy conversion in hydroelectric power plant. In hydroelectric power plant, you see, there you need to see one diagram is there in your book. So that diagram, just the block diagram you need to make here, hydroelectric power plant. So you will say that energy stored in a dam, water stored in a dam has maximum potential energy. So when the gates of a dam is opened, the potential energy gets converted to high kinetic energy. So the flowing water which having high kinetic energy rotates the turbine, and as the turbine gets rotated, turbine is connected with the generator, so electricity is produced. So this is how potential energy gets converted to kinetic energy, and due to mechanical energy, the blades of the turbine gets rotated and electricity is produced. And explain from where does the energy to run a car come from. So this one we have in our book, in the second last page of our book, just you will find out. So you will have this answer. Okay, so just near the roller coaster part, you will see that how it is connected. You will say that fossil fuels stored in a fossil fuels having a chemical energy gets converted into this heat energy which runs the steam engine. So I have explained in the video also, so you'll go through. So list the differences between energy and power. So this energy and power you need to write in your exercise book. Okay, so energy and power is also given in your exercise book, you will find out. Okay, so difference between energy and power. Okay, so and the numericals I will be teaching in the next class. So till then, goodbye. Write these question answers in your exercise book neatly and make sure that you learn those question answers and the extra question answers.